Hello and welcome to Easy Projects. So I am working on my DC load here, and I need to come up with a way to power it, because as you might remember, it needs positive 12 volts and negative 12 volts as well. And I don't have anything laying around that can provide that. I have some of these AC adapters that will give me 12 volts, and I could just use two of these to give me plus and minus 12 volts. But it kinda seems a little bit ridiculous, considering that the minus 12 volt only needs a couple of milliamps. I could also use a switching regulator configured as an inverter. But I don't have all the needed components for that, so I'll try and see if I can modify one of these to give us a negative voltage as well. But there is a few problems, because I will need a regulated 12 volt DC for the positive part. And you can see this is rated for 12 volts DC. But in order to keep this regulated, I will need a few volts above that. Thankfully, these AC adapters will put out way too much voltage in many cases, so we can hope that we have one of them here. And for the negative supply, I don't really need minus 12 volts. I could easily do with minus 5. It is only to power the negative rail of the op amps. So we will plug this in and see how much voltage we get. So I plugged it into the 230 volts, and let's measure it. And as you can see, that is way more than our 12 volts that it's actually rated at. So you actually have to be a little bit careful when you use these, because you have to make sure that your 12 volt appliance actually can handle these 17 volts. It will drop when we put a load on here, but again, I don't think it will actually drop to 12 volts. So we can try to make a little test to see how far it will actually drop. I have a 27 ohm resistor here, and that should allow us to draw 444 milliamps at the rated 12 volts. But of course, if it doesn't drop to 12 volts, we will be drawing a bit more than that, of course. So you can see at no load we have our 17 volts. And if I just connect the resistor, it drops to about 13.5 volt. And that will be at about half an amp. And I will only be drawing a couple of hundreds of milliamps. So I think that will be good enough. So now we will just have to see if we can open this very carefully. So that did make a good mess, but I think now we should be able to pry this open. And it looks like we can just unscrew the mains plug. And it looks like the blade just touched the transformer here. So I'll just have to clean this up and seal it again. Okay, so there's no center tap on this transformer, so we can't rearrange the diodes and hack into that. Sometimes you actually get lucky and they use two separate secondary windings, so that they can use the same transformer for both 6 and 12 volts. But in this case they didn't. But perhaps if we can remove some of this plastic, at least on this side here, then we can feed some wire through and make a secondary winding. I could kinda see through here and feel with my finger here that there must be around 60 windings on the secondary. I can use much thinner wire than this, because I only need say perhaps 20 milliamps at maximum. So let's try to remove this capacitor and cut away this plastic shield and see if we can feed some wire through. So now we can see through to the other side. And I just mark where the negative go. So the only wire that I have for this kind of job is 0.5 millimeter enamel copper wire. I think it could be a little bit thinner for 20 milliamps, but the next step down I have is 0.05 millimeters. And that's too thin, so I will have to use this. So I just cut off a short piece here so we can wind this around the transformer and see how much wire we need for one winding. So we can kinda get an idea how much we will need for 60 windings. So this is now the length of one winding, and it measures 12 centimeters. So we should use about 7.2 meters in order to get our 60 windings, but I don't think we will be able to fit that, but we will try to get as close as possible. So now it's just to feed this through a whole bunch of times. So that didn't take long, or perhaps about an hour. So if I could just go and buy this, it probably wouldn't be worth my time. I didn't manage to get all 7.2 meters in there, but I think I got at least 5.5 meters. So now we just have to measure the AC voltage of this new winding, and we can kinda get an idea how much DC we can get. And to test it, I have just plugged it into an extension cord and put it on the table so it cannot touch anything. And I can just turn on the switch and see if we will blow anything up. Well, we didn't blow anything up, but the voltage is a little bit low, I think. But I think it will be okay, because if we take the 4.9 volts and multiply them by the square root of 2, that will convert the RMS voltage into the peak voltage. And as you can see, that is 7 volts. I think I should be able to get my 20 milliamps out of that. I can just try and hook up a 100 ohm resistor, and that should allow us to draw 50 milliamps. And as you can see, it is not dropping much at all. Only 0.1 volt, so hopefully that should be good enough. And it doesn't look like I destroyed the other winding either. But remember, I did remove the capacitor, so we kinda expect this value to be garbage. So instead of your more traditional bridge rectifier, I think I will go with a half-wave rectifier. Normally the bridge rectifier will be the best choice, of course, because that will charge up the capacitors at double the rate of the mains frequency, because you get all the negative parts of the waveform flipped up to the positive side. On the half wave, you will simply just cut off the negative part, so this can drop a bit further before it gets recharged. But the benefit for us is that up here you can see no matter which path the signal takes, it will have to go through 2 diodes. And that will of course mean that we'll have a voltage drop of about 1.2 volt, roughly 0.6 volts per diode. And if you look down here, we will only have 1 diode, so we will only lose 0.6 volts. It will mean though that our capacitor here have to be a little bit larger, but since we're only drawing 20 milliamps, that shouldn't be a problem. And I guess 20 milliamps is the absolute maximum. It will probably never get to there because it's just the op amps that we're powering. So I have got our little board soldered up here, and one of the AC lines are coming in here and the other one here, and we will also use this as a ground. We have the input cap, an output cap, and the regulator, and I have the output over here. I have also connected the negative lead of the multimeter to the ground and made sure that nothing is touching here, and most importantly nothing is touching the mains. So I'll just measure this and make sure that it will regulate. And now I can plug in the mains and turn it on. And let's start by measuring the input voltage at the input capacitor, and that's only minus 6.16 or minus 6.10 actually it drops to sometimes. But the important part is if it will regulate. And we do have minus 5 volts at the output, so it seems that it is regulating. So I have just tried to hook up the 100 ohm resistor again, and let's measure the output now. And unfortunately it is starting to drop. So this might work, but of course there's also the chance that it won't work. At least we can say that it is right on the edge. But changing that diode there to a Schottky diode instead will give us at least 0.2 volts more headroom. So I will just try and change that. And there we go. I changed the diode, and without the load we of course get the minus 5 volts. So now let me try and hook up that 50 milliamp load again. And unfortunately it does drop a little bit. So I just turned on the oscilloscope, and if you just watch the screen there while I measure the output, you can see it turns out we might actually be lucky. Let me try and move the probe to the input capacitor. And you can see all this ripple is of course what is causing the output to drop. It turns out that my 1000 microfarad input capacitor is not enough. So I should be able to just increase the capacitance to lower this ripple, and then the output should be fine. Unfortunately I didn't have any low voltage, high capacity capacitors, so I had to use a 50 volt. But if we look at the multimeter now, you can see it is only dropping about 10 millivolts now. So we are just at the maximum current now, and I am drawing 50 milliamps, and there's no way my op amp is going to draw that much current. So, but still, we're not quite safe yet, because we don't know what will happen when I hook up the 12 volt rail. So let me try and do that. And this is with half an amp of load on that rail, and that is never going to draw that much either. So, and with a more realistic load on the -5 volt rail, it doesn't matter if I hook up the half amp load on the 12 volt. So I think this will just about do, but I kinda would have liked to have a little bit more headroom. So I just soldered in the 12 volt regulator as well, so we can test it with the actual circuit board. So I have hooked up the -5 volt and the +12 volt to the DC load, but I have also hooked in another 100 ohm resistor on the 12 volt rail to simulate when the fan is running, and that will be all the power that I will ever draw from this. So let's turn it on and see if it works. And it powers up. And let's measure some voltages. The 12 volt, that is 11.85, and if we measure the input, that is 15 volt. So that should indeed be regulating. I can just try and disconnect the extra 100 ohms here and measure it again, and it's still the same. And I connect the 100 ohm load back on, and we will measure the -5 volt, and that's also regulating. And I can just check the input voltage, and that's -6.4. There's not much margin, but it does work. So I hope you like this video about how you can hack a transformer to get an extra rail. Of course, you don't want to do anything to the primary side, because that is the mains voltage, and you don't want to mess around with that. If I had some finer wire, I guess it would have been a little bit better, because I could get some more windings on there. And that will of course mean a higher voltage, so there would be a little bit more margin on the regulator. I could perhaps have tried and pull this plastic out, but again, it is there to protect the transformer, so it's kinda better to leave it. I will have to add some glue to this so it won't unwind itself, and I'll have to put a proper plug on here, of course. But I will do all that when I have to put it into the enclosure. Anyway, if you did like the video, please give it the thumbs up and subscribe to my channel. And I will catch you soon for the next part. See ya!